Hello guys, so today we'll be discussing another very important topic, that is about something about acids and bases. We are going to basically discuss basicity of acids. So let's understand what we mean by basicity, and obviously we'll go a little bit into base also. What is the basic difference between base and why this difference is so. So if you see this one, I have drawn some acids. The specific thing that I have drawn over here is the structures. Okay, while we are talking about the basicity of the acid, it means this word means number of H plus or H3O plus ions given by one molecule of acid when dissolved in water. Okay, so this goes about the definition. So first of all, I have to dissolve this acid into water. Okay. So water is a very specific property, is that it has high dielectric constant. Dielectric, I have written D dot here, constant. The value is 80. What does this mean? It means it tends to weaken the bonds between various atoms by 80 times. Okay? It weakens the bond between two atoms by 80 times. If you want to experiment, do one thing. Take a potato in your house. At this moment it must be available. So, and put it in water. And then take it out after 1 hour. After that, even if you just give a little bit force, it will be very easy to peel off the potato. जो छिलका है, that can be the skin, you can take it out very easy. So because it has weakened the force of attraction between the peel and the inner part of the potato by 80 times. Okay? Similarly, it does the same for all the molecules that is dissolved in it. Okay? Why it does so? That is another part that we can discuss in a other video. At this moment, for this, understanding this, we need to know that water is going to weaken the bonds. So this is the first acid if I talk about. So this is hydrofluoric acid, that is HF. Fluorine is very electronegative with respect to hydrogen. So what does this bond means? A bond means two electrons. ठीक है, ये हमेशा याद रखना. One bond is equal to two electrons. And what is electron? Electron is cloud of negative charge. So in this case, as fluorine is much more electronegative, fluorine is going to pull the negative charge towards itself, and the bond will basically be like this, the negative charge towards the fluorine. In such kind of bonds where most of the charge is taken up by the negative charge, this kind of bonds are not that strong. Why they are not that strong? They can be broken easily. Okay, why they can be broken easily? Because one part of it is very thin, right? So you can easily break this. So whenever you give it in water, water will further reduce the force of attraction, weaken this bond by 80 times, and this part will be broken very easily. If this is broken, electron is, anyways the electrons are towards which side? Fluorine side. So hydrogen, when it gets liberated from HF, will be devoid of electron, and it releases one H plus ion from a molecule of HF. So this is the reason the number of H plus released over here is only 1, and that is why basicity of HF is 1. If you consider HCl, similar things will happen, and here also basicity will be 1. Okay. Now let's take a very important acid, that is sulfuric acid. Okay. So in case of sulfuric acid, if you see, okay, see this one. Here is the bond between oxygen and hydrogen. Here the electronegativity difference is again very high. So it will basically be like this, right? So it will be easier for water to create its force, which will weaken these bonds by another 80 times, and this is going to break, leaving behind the electrons towards the oxygen side, and 2 H plus will get released. So per molecule, how many H plus is getting released? 2 H plus is getting released. So in this case, basicity is 2. Okay? Now coming to this one, this is phosphoric acid, H3PO4. Phosphoric acid, okay? H3PO4. So if you see this one right at this moment, the number of OH bonds are 1. This will break, this will break, and this will break. So its basicity will be 3. So you can see in this kind of acids, these kinds of acids are called basically oxyacids. Oxyacids. Wherever there are OH group in acids, it will be called oxyacids. If there are no OH groups like this, these are called hydracids. Okay? So basicity is 3 over here. What do you think? What will be the basis? This is basically H3PO3, that is phosphorus acid. Phosphorus acid. Okay? So in this case, there are 2 OH bonds. So this will break, and basicity will be 2. Okay? This is hypophosphorus acid. This is basically H3PO2. Only one OH group is there. So basicity will be 1. Okay? So basicity for oxyacids, or sometimes it is called oxoacids also. Okay? So basicity of oxyacids will be the number of OH group present in the oxyacids. Except there is one acid which is called boric acid, H3BO3. It has 3 OH groups, but its basicity is 1. Okay? So this is out of your scope. This will be taught in class 11. Okay, so I hope the basicity is pretty clear to you right now. I would just want to show you one thing. So anything that releases H plus should be an acid, right? And you now know the mechanism how the H plus is getting released. Now let us take this one, NaOH. Okay? This is ionic compound like this. Okay? So in this case also you can say, sir, whenever I put this in water, it should give H plus out. But it doesn't give. Why it doesn't give? Because the electronegativity difference between Na and O, the electronegativity difference is very high. Right? More than electronegativity difference of O and H. है ना? इसका electronegativity difference बहुत ज़्यादा है, and that is why it forms ionic bond. And whenever you put this in water, it separates into ions. ठीक है? Water में दे दो, and it gives Na plus plus OH minus. So it separates from this place, right? Why do it separate from this place? Due to the reason that electronegativity difference here is very high. It is just the force of attraction is there, no sharing of electrons, complete transfer of electron was there. Okay? So that is why it separates from this place. Okay? That is why it gives OH minus in the solution, and that is why NaOH is a base, but H2SO4 or anything like that is an acid. Okay? So see, NaOH is a base, but I'll just show you another one, ClOH. Okay. This is an acid. Why? Because here remember, oxygen is much more electronegative than chlorine. So electronegativity difference over here is much higher. इसमें उतना नहीं है. ठीक है? So it will break from this side, okay, and it will give H plus, and that is why ClOH, which we basically call HOCl, okay, sometimes people call it HClO also, hypochlorous acid. Okay, so this is an acid, but this is a base. Clear? I hope this is clear to you, and I hope you will be able to complete the homeworks and everything that is related to this one. Thank you.